Today's very short lesson is just really an extension of yesterday. How can we use probability to make predictions? So we have some data here. Here's our data. They sold 75 lunches. I don't know if it was at a restaurant or a cafeteria, and they sold them in 30 minutes. And here's how they broke down. 20 lunches of pasta, 15 of salad, 25 sandwiches, 15 stir fries. Okay? So there's our data to work with. Now, a prediction is a statement about a future event, something that you think will happen based either on an experiment or based on just knowledge that you have, past experience. So if this cafeteria sells lunches for 30 minutes, how many salads do you think they would make and sell if instead of 75 lunches, it was 30 lunches? Excuse me, 300 lunches. Do you think that the salad numbers would go up or down? Up. Okay, so what do you think we're going to do here? Well, if we look at this table, right now we have what would be our fraction. Our fractional probability is 15 over 75, right? Yeah. Now we can simplify that. But if we simplify, we're not going to make our digits, our numbers, larger. So we want to predict how many in 300. So let's take 15 out of 75, which is what we have now. But we want to try to figure out, instead of 75, we want to make it 300. Do you remember how to make an equal fraction?
Yes.
How?
You have to do the same to the bottom.
That's right. How did I get from here to here? Two 75s make 150, right? So you're right. So up here I'll do the same and get 60. So if we sold 300 lunches, a good prediction would be about 60 of them would be salads. Let's do the same thing again, except this time what if we only sold 150 lunches? How many then do you think would be salads? Lingen? How did you do that? Times the top and the bottom by 2. Then 30 would be salads. Okay? All right, let's do some other examples like this. Okay, so I made a hot dish, and when I scooped it onto my plate, there were 25 noodles on my plate. Okay, 25 big, thick noodles. I ate 15 out of those 25 noodles. Okay, now what if I cut the size of those noodles down, and this time there were 125 noodles on my plate. The noodles are smaller this time. About how many do you think I could eat if I had 125 on my plate? Remember, the noodles are smaller now. What do you think, Darius?
75.
Tell me what you did.
25 times 5 equals 125, so you have 15 times 5.
Does that make sense? I cut 100 pieces of wood to heat my house last winter. I only needed 60 of them. Okay, that's all I needed to heat my house all winter. This winter, it's supposed to get way colder. So I cut 200 pieces of wood. How many pieces do you think I would use if it was the same percentage, the same ratio? How did you do that? Okay, you knew that to get from 100 to 200 you multiplied times 2, so he did the same to the top. Good work. I have 50 pair of shoes in my closet. And I decided that I am going to keep 28 of them. Okay? 28 of them are in good shape, the rest are not. 28 in good shape. Okay? Now, my friend, who is amazing, she has 250 pair of shoes. But the same percent, or the same ratio, she needs to get rid of as well. How many out of 250 is she going to need to get rid of? Tell me what to do, and I'll do it. I know you won't be able to do this one in your head. Will.
You have to take 50 times 5. And 140.
That's a lot of shoes. She better donate, huh?
At least that much. And you have to double 140.
Let's take a look at some questions that we can use to practice today to make sure we understand this concept. Maria has a bunch of buttons. Brendan, can you please put your pen down? Then you'll need to clean that table after. We don't write on the tables. What were you doing then? Just put your, okay. She has 9 white buttons, 7 red, 10 yellow, 8 purple. If she takes one out of a bag without looking, what color is most likely going to be chosen? Eileen, what color will most likely be chosen out of that big bag?
Yellow.
Why?
Because there's more.
That's exactly what I wanted to hear. There's more yellow. Here's a spinner. It is divided into 4 equal parts. Let's pretend the spinner is spun one time. Which of these statements is true? A, each outcome on the spinner is equally likely. B, J's most likely, T's most likely, or R's most likely. Aiden. Why?
Because they're all the same size.
That's right, they're all the same size. So Tanya tossed a number cube, like a dice. What event is least likely? Alexis. Right here. Which of these events is least likely? Tossing an odd number, tossing an even number, tossing a 2, or tossing a number greater than 2? Alexis, which one is least likely? Okay, tell me why. How many chances would there be to roll a 2? 1 out of 6. What are the chances of tossing an odd number, Sam? 3 out of 6, which is the same thing as? 1/2. How about an even number, Sam? 3, 6, or 1/2. Cole, how about tossing a number greater than 2? 4, 6, which is the same as? Simplify, simplify. Natasha? 2/3. That a girl? So each friend at Mac's birthday party wrote his name on a piece of paper and put him in a hat. And Mac's going to draw one name and give a prize to that friend. How many different outcomes could there be? Aiden? 7. Because there are 7 different names, right? What would happen, Aiden, if there were 2 Bens that came to his party? 2 Bens. 2 kids with the name of Ben. Yeah, that's right. I think they better put a last initial. Let's suppose, here's a tricky one. Listen carefully. Suppose you toss a coin. Which event is certain? Heads up, tails up, heads up and tails up, heads up or tails up? Caden? Yes. You can't get both when you toss a coin. You won't always get this. Certain means it will for sure happen. It's going to be one or the other. It's not going to land halfway, right?
Yeah, it's like it lands in the
Okay.